The next force that we will discuss is the anterior-posterior force and the associated horizontal plane rotational force. Now, anterior-posterior force in just general human motion refers to our ability to create force both anteriorly or in front of the person and posteriorly or behind the person. Now, just like the other forces that we've talked about, this force is going to precede the motion that we see in the anterior and posterior direction. Now, some of my favorite examples of this are something as simple as like a broad jump, like if I were going to jump towards you. Now, again, I want my ground reaction force to be pointed towards you so that I can jump in that direction. But remember, that's going to be the external force. And because of Newton's third law, that's actually going to come from me pushing really hard into the ground to my posterior direction or to the back of this direction. That's going to create a ground reaction force that's going to be able to propel me forward in that anterior direction. Now, again, I could flip that around and say, well, now I want to jump backwards. Well, the way I'm going to jump backwards is I'm going to take my feet and I'm going to push as hard as I can forward or in the anterior direction and create a ground reaction force that's going to shoot me backwards. That's kind of a cool component of the anterior-posterior force. Walking is a great example of the anterior-posterior force. This is an example of how we actually utilize our feet to create forces that are going to propel us forward in walking. We do that every single day. Now, one of the cool things that we can do with the anterior-posterior force is we can actually take our feet and instead of using them in conjunction, pushing in the exact same direction, we can actually flip things around and actually utilize our feet pushing in different directions and create some horizontal plane rotation. One of my favorite examples where we can actually talk about this is in an inner tube example. Now, if I'm sitting around an inner tube, I actually like to think about where I'm sitting. Think about that as the axis that I'm rotating around. Now, we've talked a lot about torques, and a torque would be a description of how we're rotating around this vertical axis, right? An inner tube that would be spinning around that open hole, right? Now, I could do a couple of things when I'm inside this inner tube. I could propel myself in the anterior direction by utilizing both hands and propelling myself forward at the same time. Or what I can do is I can flip the direction of one of those applied forces. Now, because these applied forces are each going to have a moment arm relative to this axis of rotation, I've now created a torque. And I could call that this horizontal plane rotational force. That's another way to talk about torque. And as I create this motion, now instead of my inner tube moving forward, now I'm going to rotate around this axis and I'm going to create this spinning effect of this inner tube. I could do the same thing with my feet if I think about the overall center of pressure, the individual points of application for the forces from my trail leg and my lead leg, and I could start to think about pushing in opposite directions, and now I can create this horizontal plane rotation or a torque that's rotating around that vertical axis. Again, those would be the same thing, right? And I can utilize those, creating this force couple to create that rotational motion that I desire in human movement. Now that we've talked about how that can work in general human motion, let's dive into some details on how we can utilize these forces and the associated torques to create the motion that we want in the golf swing. In the golf swing, these anterior-posterior forces are incredibly important as we start to discuss horizontal plane rotation or torque around the vertical axis, right? These are the rotations that are going to do a couple of key things in the golf swing. The very first thing that we're going to see is that body or that golfer is going to actually rotate. Their hands are going to move away from the ball, away from the target. The club is going to move away. The chest is going to turn and move away, right? This is that first negative rotation or the negative horizontal plane rotation that occurs in the backswing. Now, what we definitely want to see is that golfer, after they're turning away, that there's going to be a turn towards the ball, towards the target. Now, when should this occur? Well, in really good players, this tends to occur much earlier than you might think, right? An amateur golfer might come up to here and say, oh, I'm going to now initiate the downswing and start creating all of this turn, create all of these really good force couples with the anterior-posterior forces and create this associated rotation. But what really great players do is, honestly, by the time they get to about arm parallel in the backswing, they're already going to start creating this positive horizontal plane rotation so that they can stop the turn backwards and create some initial turn forward so that now their club can kind of fall in position and now they're ready to complete that turn and get a lot of power into the golf swing. Now, the purpose of this horizontal plane rotation is to help us turn that body, but it's also a really key component of actually getting the golf club to start moving back in front of us and towards the ball through impact. This is how those anterior-posterior forces work in conjunction. And what they're doing is they're creating that powerful force couple. The downswing is where we see it the very most. My trail leg is going to push really hard away from the ball, creating a ground reaction force that's pointed towards the ball, while simultaneously my lead leg is pushing really, really hard into the ball, creating a ground reaction force that's pointed away from the ball. Those two forces working in powerful conjunction together will create a really powerful horizontal plane rotation that helps us sync things up and deliver a lot of power to the golf ball through impact.
Now that Dr. Tyler has explained the concept of horizontal plane rotational force as well as anterior-posterior force, now we want to come back here in the lab and look at those things in the app and talk about our performance pi. So the first thing we're going to do is look at horizontal plane rotational force. Tyler, can you just explain kind of this idea of rotational force and torque for us again?
Yeah, and honestly, for all intents and purposes, Tyler, I think we can think about them pretty similarly, right? It's about this concept of creating rotation either around an axis or kind of in a plane as it spins around. And so we could call this torque the vertical torque as it spins around the axis, or we could call it this horizontal plane rotating, thinking about that body creating that rotation. And so horizontal plane rotational force is equal to vertical torque. We're going to describe it as that horizontal plane rotational force throughout this video.
Of course, just remembering that what we're showing in the app is that rotational force or torque. It's not the motion.
Exactly.
The first thing we're going to do is just talk about what is positive versus negative horizontal plane rotational force and anterior posterior force in the app and how to really look at that. So if we look here at our graph for this horizontal plane rotational force, you can see that at the start, it's basically zero, and that just means there's none of that rotational force and no tendency of motion to rotate away or towards the target. When we see this yellow line drop below the 0x axis, this is showing a negative horizontal plane rotational force, and that would mean we'd see a tendency of motion of rotation away from the target. And as soon as this yellow line goes above the 0x axis, that's a positive horizontal plane rotational force, and that would be showing a tendency of motion rotating towards the target. Is there anything you want to add there?
Yeah, again, just keeping in mind that it's not about when it turns and goes towards the zero. Let's use that zero line as that point where when we're above that, that's a tendency of motion towards. Below that is a tendency of motion away.
I think this is a great place to also look at how we show the horizontal plane rotational force in our vector view. And we do this by showing a circle that lights up around the total center of pressure point. Now, when we have negative horizontal plane rotational force, that circle will light up as black, as you can see here. And when it's positive horizontal plane rotational force, or it's above the 0x axis, that circle will light up yellow. You'll also see that the size of that circle will change, which is just showing a difference or a change in the magnitude of the force, which we'll get to when we talk about our performance pi. The next thing we want to do is talk about anterior-posterior force and how that contributes to the horizontal plane rotational force, as Dr. Tyler has already explained to us. So we'll look at this FX, anterior-posterior force graph here. Anytime I see one of these lines above the 0x axis, as I do with the red or trail foot here, that would be indicating a positive anterior-posterior force. This means that I'm pushing in the ground with this trail foot away from the golf ball, and the ground reaction force is pointed back towards the golf ball. We could see this really clearly, obviously, here in the graph, as well as with the vectors on the top, where we see the red arrow pointed towards the golf ball. Opposite of this positive anterior-posterior force on the trail foot, we can see anytime one of these lines is below the 0x axis, as you do here with the lead foot, that's showing a negative anterior-posterior force. This means that I'm pushing into the ground towards the golf ball, and the ground reaction force is pointed away from the golf ball. You can see that again here with this vector view on the top where the arrow is pointed away from the golf ball. Tyler, could you just quickly talk about what negative and positive anterior-posterior force means in terms of motion?
Yeah, again, generally speaking, we're talking about anterior-posterior motion, so towards the golf ball or away from the golf ball. So anytime we see an overall yellow curve that is above the zero, that would signify a tendency of that motion being kind of towards the golf ball in that anterior positive direction. Anytime we see that yellow line drop below the zero, that's going to signify a tendency of that motion away from the golf ball. The other thing that I think is really kind of cool to look at here, Tyler, and we can see this in other views as well, but the graph view is the first place that we're going to see how these feet work in opposite directions in that anterior-posterior direction. And I talked previously about this idea of a force couple, and I think you can see this really well in the 3D force vector view and on the graphs, where you can see that these feet are actually pushing in different directions, resulting in a ground reaction force from each of those feet that is pointed in different directions, and that helps us build that horizontal plane rotational force that we've discussed.
Another place we can look at the horizontal plane rotational force as well as the anterior-posterior force is in our dashboard. Tyler used this great analogy of an inner tube in a pool earlier, which I think this dashboard actually shows really well. So in the middle of the dashboard, you'll see the horizontal plane rotational force, just as we saw in the vectors, shown with this kind of circle that changes in size. And on the sides where you see Fx, this is our anterior-posterior force. So for example, right now you have a negative anterior-posterior force in the lead foot, and you have a positive anterior-posterior force in the trail foot. And you can imagine that almost with your hands, right? If I was pushing in the direction of those colors on the bars, that would create the spinning. And as those bars get larger, you also see more horizontal plane rotational force.
Yeah, I love the visual of this, Tyler, because I think if you kind of move back and forth, you can watch that red and blue bar get bigger. You see that they're counteracting each other. We call that the force couple. So they're acting in opposing directions. And then you see this cool axis of rotation in the yellow, which is basically the middle of that inner tube. And as those red and blue lines get bigger, that inner tube kind of blows up, that yellow rotational force gets bigger and bigger, and now we're starting to create these really powerful horizontal plane rotations.
The last thing I'll add here is that when you see this circle as shown as yellow, that's showing positive horizontal plane rotational force. Again, a tendency of rotation towards the target. And when it's black, as you can see here, that's showing a negative horizontal plane rotational force, or a tendency of motion rotating away from the target. Now that we've talked about how to look at these two things in the app and what positive versus negative means, let's turn to our performance pie. You'll remember that the first piece of our performance pie is the kinetic sequence and timing. So if we look at our kinetic sequence graph, you'll see that the horizontal plane rotation force, shown here with this kind of lighter yellow color, is the second to peak in the kinetic sequence. Now, we always want to see horizontal plane rotational force peak second. It might not always do that for every golfer, but it should. Do you want to talk a little bit about that?
Again, when we think about the purpose of this horizontal plane rotational force is to start to kind of turn the body towards the target. It's also trying to bring the club from the back of the body, kind of starting to move it to the front of the body. We want that to occur for sure, but if it occurs too early in the process, even before some of that lateral force peaking that we talked about earlier, now we can get into some trouble of kind of throwing things over and around the golf ball instead of syncing things up correctly.
Absolutely. So just to go back a little bit, we've done lateral where we've kind of started to shift our center of mass towards the target. Now we want to start to add that torque where we start to rotate a little bit.
For sure.
Now that we've talked about the sequence, let's talk about the timing of this peak. So we always want to see the horizontal plane rotational force peaking between lead arm at 45 degrees in the downswing to about lead arm parallel. That's kind of our dynamic window for peak horizontal plane rotation force. By peaking this rotational force at this time, that's going to allow us to get the timing of the actual motion, or bringing the club from behind us to in front of us at the right time as well. The second piece of our performance pie is point of application. Tyler, I'd love for you to talk a little bit about the line of pressure as well as these center of pressure points for the individual left and right foot.
Yeah, and mostly what I really like to track when I'm talking about point of application is just that line of pressure number. For a player to create nice rotational force in this plane of motion, we definitely want to see that as they're creating it, we see a time where they have a nice positive line of pressure. And that would just be signifying that point of application of the lead foot, or the blue dot, is a little bit further forward than the point of application of the trail foot, or the red dot. And I get that positive value because then what I can do is now I can kind of flip that as I finish off that swing a little bit. And now I can get that to go to a negative value as I'm really generating a lot of this horizontal plane rotational force. And so this is a player that actually does a pretty decent job of it. I definitely see players that have a more positive line of pressure, but the important thing is his line of pressure is positive, and then we can see as we scroll through that it flips negative, and that's going to give him a lot of nice leverage and mechanical advantage to create this type of force.
Absolutely. I think that's a great kind of description of point of application. You can imagine, as we've talked about a little bit earlier, is that if we have a more positive line of pressure, how that would affect the club coming from a better position than maybe if it was more negative and we were getting a little bit out over the top, as some would say. Great. The third part of our performance pie is magnitude. And again, magnitude is just looking at how much of the force there is. Our threshold for horizontal plane rotational force is 85 Newton meters per mass. And again, similar to when we talk about lateral force or vertical force, this is just kind of normalizing the amount of rotational force to that person.
Yep.
So remember, this isn't necessarily a PGA Tour average or something that every person has to do. It's just a starting point. We'd like to see any golfer be able to get up and touch this threshold. Tyler, do you want to talk about magnitude at all here?
Again, the magnitude of this is going to be related to the quantity of rotational motion that the player has. And remember, the golf swing is rotational, right? So definitely we talk about all these other forces, but this rotational torque ends up being a really key part of the process. And so having a value that gets above that 85, this is a player that goes all the way up to, 150 plus. This is a player that's creating a lot of rotational force. You can see in that 3D force vector view a really big yellow value. He's getting a lot of tendency of motion, turning himself back towards the ball, back towards the target, which is what we'd want to see in the swing.
Excellent. I think the last piece we need to talk about, as always, is the shape of the curve. So we're just going to walk through and talk a little bit about the shape of the horizontal plane rotational force curve, as well as the anterior-posterior and how they contribute. So let's go back to address, and we'll notice here right away we see 0 horizontal plane rotational force. This just means there's no motion. There's no rotation away or towards the target. And the first part we're going to look at is, again, this valley of the graph here, and this is our kind of peak amount of negative horizontal plane rotational force, or the force that would cause us to rotate away from the target. Do you want to talk at all about kind of the timing of this and so on?
Every golfer is going to rotate away from the target, right? They have to rotate away from the target. And so you can see here, right, that he's doing this quite early on in the swing where he reaches this maximum negative value that occurs here. And then what's really cool is you start to see as that curve starts to turn and starts to get less negative, that signifies that already in his swing in this point, he's starting to produce less negative horizontal plane rotational force, which is saying that he's not just turning away from the swing forever, right? He's doing a very good job of turning it on quickly and starting to turn it off quickly so that we can do the next part of the motion.
Yeah, absolutely. I think while we're here, let's talk a little bit about how each foot and the anterior-posterior force is contributing to this. So if we go back to this graph here, we'll see a positive anterior-posterior force from the lead foot and a negative anterior-posterior force from the trail foot, or in other words, that force couple. Do you want to explain that again?
Yeah, again, this is just a scenario where the ground reaction force from the lead foot is pointed towards the golf ball. The ground reaction force from the trail foot is pointed away from the golf ball because they're acting at distances from that axis of rotation or that overall force vector, the yellow vector on that 3D vector view. Now what we're getting is this force couple, right? They're working in conjunction with each other, and they're helping create that negative horizontal plane rotational force or that motion away from the target.
I think another great way to talk about this is just the tendency of motion. So a positive anterior-posterior force from my lead foot is going to cause a tendency of motion in my lead hip to move towards the golf ball, and a negative anterior-posterior force in my trail side is going to cause a tendency of motion in my trail hip to move away from the golf ball. So you can imagine how that would cause rotation away from the target or in the backswing. Let's go back to horizontal plane rotational force and start to talk about our next point, which would be where that kind of crosses the 0 axis and becomes positive. Tyler, why is that so important?
Yeah, because what this positive horizontal plane rotational force has to do is first it has to stop that turn away from the golf ball. Then it has to initiate that move towards the golf ball. And so this player is doing it beautifully, where you can see that he crosses the 0 around arms parallel on the backswing. think this is what we see in really good players, where they're already working to stop that motion backwards so that they can create the motion that they need forward. And so I think a lot of golfers will tend to get to that. They'll build up a lot of the negative, and then they cross the zero super late, and then it just takes forever for them to create that rotation through, and then it's like they're just throwing everything at the ball really late.
And I think, again, this is a great place to talk about anterior-posterior force, where you'll see they basically are crossing each other at zero, and those vectors in the top right are pointed straight up and down. So neither one of them is pushing towards the golf ball or away from the golf ball. It's just kind of neutral at that point in time. We've already talked quite a bit about this peak, so let's go in and talk about the anterior-posterior forces and how they contribute here. So if I look right at the peak of the horizontal plane rotational force, and I go to the anterior-posterior force graph, you'll see that those are also right at the peak. So we've talked a lot about how we create rotation with this force couple. Explain that here.
Yeah, I love to see these two graphs synced up at this point, meaning they're both reaching their maximum positive or negative values at the same time. This shows that they're really working those 2 feet together at a really nice time. And a quick thing to look at is when these are peaking. You might see someone peak the lead before the trail, and that's just kind of an indication that they're not doing a very good job at efficiently using those two forces together. So that's the very first thing I like to look at here. And again, this player is syncing them up really nicely.
We also want to talk about the lead foot versus trail foot contribution with anterior-posterior force here. Could you explain that?
Yeah, I think this is a cool one to look at and bring in this yellow line, or the overall anterior-posterior force. Remember, positive showing a tendency of motion towards the golf ball, negative a tendency of motion away from the golf ball. And you can see that what this player is doing is they're almost equally contributing from trail and lead, right? 24 from the trail, 23 from the lead. And this is a player that's using those both kind of together simultaneously. Now, what I definitely don't want to see at this point of the swing is a lot more trail contribution to this than lead contribution. Because what that will do is it will take that overall yellow line, it will make that much more positive, and will create this tendency of motion kind of towards the golf ball. And that ends up really kind of limiting the space the golfer has to kind of drop those hands and deliver them through the golf ball. Now, if we scroll through just a little bit further, you can see as he's starting to come in through impact, I love to see that yellow value get more and more and more negative as he almost turns off the trail leg. The trail leg is no longer creating that anterior-posterior force. The lead is still doing a nice job of pushing. And so now we see that total combined anterior-posterior force be in the negative 11, 12, 13 range. And that's going to create some nice space for him to deliver his hands on a good plane into the golf ball.
Yeah, absolutely. When we talk about the peaks of these anterior-posterior force, we generally want to see about 1.5 to 2 times the amount of lead leg negative anterior-posterior force than we do positive in the trail foot. Is that right?
Yeah, the lead leg, we describe it a lot, and I've heard it described as kind of the gas pedal, right? Like it's doing a lot during this point of the swing, and so getting it activated and working well is really important. And again, I think that 1.5 to 2 times more is a good ratio. Again, this is a player who maybe at this point isn't quite there, but if you fast forward just a little bit in the downswing, he definitely surpasses that really nicely and gets the motion that we would want to see.
Great. I think that kind of concludes our discussion of shape of the curve and the performance pie for horizontal plane rotational force and anterior-posterior force. Let's head back outside and take a look at some of our favorite drills to train this.
We've just finished extensively going through the anterior-posterior forces and some of those associated horizontal plane rotational forces or vertical torques that are occurring in the golf swing. Now let's step through just a couple of our favorite drills that we think can help with some aspects of the performance pie with this force. Now, one of the aspects, Tyler, we talked a lot about is the importance of that line of pressure, that green line that we look at, especially for a player that's trying to create some of this power from this rotational force in the horizontal plane. And it's important that we understand that there's a little bit of a difference between what they're doing on the trail side than the lead side. And so when you see that, a player who just kind of migrates that line of pressure up, using something like a force pedal can be a great way to feel where they need to be pushing on the ground. So I'll have you take your normal golf stance. And again, the key here is we just want to make sure, of course, we want the lead foot coming through the ball of the lead foot. Okay, that's kind of that's the universal place that we want that force to be traveling through, that lead foot. And then back here, we just want to make sure that this is going to be back a little bit farther in the foot. So we're going to put it more in the middle of the foot, even a little bit towards the trail. And all we're going to do is kind of feel like you're kind of really pushing hard into those force pedals to feel that as you kind of finish off that swing and then really initiate that early downswing.
Yeah.
Okay. Okay. And again, this is one of those things that, especially if you have a player who has no concept of how or where to push on the ground, this is such an effective way to throw these force pedals under the feet, just place them in the locations you want them to feel that point of application. And it's awesome to see that when you can clean up the point of application, some other things tend to start to fall in line.
Yeah, what we often see when we do this drill actually on the force plates, which you can do, is you'll see that person all of a sudden that line of pressure will really start to tilt in the positive direction, which is really what we want to see. And then I just think it's important to make sure you add the cue of also then once you get there and feel that pressure is to really kind of then push off of the force pedals to create that AP force going back in the other direction.
Yeah, and I think that's a great segue, Tyler, into a second drill that I think we think can be really effective as well for this. And that's a drill that our friend Jason Zubak refers to as the super drill. And he calls it the super drill because, frankly, it's probably a drill that you could utilize for any of these forces and torques that we're talking about. But I think this is a great place to start to really feel what you've just talked about, which is not just kind of a passive kind of, hey, I'm just kind of throwing things down, but really creating this power through the swing, right?
Yeah.
So let's kind of walk through this super drill. Okay? So again, taking that stance, kind of getting in that position, again, still utilizing a force pedal to help that player really learn how to push through the ball of that lead foot because it's such a key component of that force. But this is a scenario where we want to really see them start to create so much force that we're actually going to start to see some rotation, right? That foot's now working in this direction. Remember, anterior posteriorly, we want that foot to push really, really hard towards the ball, which is going to create a reaction force that's away from the ball, and we want to really see that foot travel posteriorly in a really aggressive, active motion. Awesome.
Yeah, so kind of this idea of like Jason, I think, always talks about pushing kind of 1030.
Yeah.
Like I'm pushing this direction kind of down into the ground, not only straight down, not only this way, but kind of right in between.
Yeah, that lead foot is doing so much in the downswing, and I think one big aspect of it is the key of that anterior-posterior that we walked through in the app, that we looked at in the golf swing. So this is a great drill to access what that lead foot should be doing. Again, we have lots of great examples of other drills to improve these anterior-posterior forces, to improve the associated rotational forces that occur in that horizontal plane, or the torques around the vertical axis. So again, check those out. A lot of great things from our friend Jason that we work together on as ways to help your player improve these forces in the anterior-posterior direction.